And we will review last Friday. We worked on the midpoint formula, and maybe you're going to remember that if we have the xy plane, and we have 2 points on this plane, point 1, and point 2. Point number 1, point number 2. We have 2 different formulas to find information about these points. First, we can find the distance between these 2 points. There's a formula about the distance, and after there's another formula about the halfway, about the midpoint. We can find the point that's right here in the middle. It's called midpoint. And for that reason, for that purpose, we have the midpoint formula. It's very simple. It's just the average of the coordinates x of point 1 and point 2 and the average of coordinates y of point 1 and point 2, right? So let's say point 1 have those coordinates here. Point 1 is x1 equals -4, y1 equals 6, okay? And point 2 is this, x2 equals 8, and y2 equals 1, right? How do we find the coordinates of the midpoint? Well, we apply the midpoint formula, and we're going to have the average. We get x1 plus x2 divided by 2 is this, and y1 plus y2 divided by 2 is that, right? But something's missing. If you look at the last line with the answer, the midpoint of the segment is the x coordinate of the midpoint is missing. We just have the y coordinate of the midpoint. Can you help me find the x coordinate of the midpoint? The y coordinate is here. We can also confirm, we can see 6 plus 1 over 2 is 7 over 2. Okay, it's here. But the other one, we don't have. X coordinate is missing. Tell me. Answer. 1 over 2 simplified. Yes, Timothy, thank you. It's kind of right, but you have to invert. 1 over 2. You invert because you have -4 plus 8 divided by 2, right? -4 plus 8 is 4 over 2, and this is 2 over 1 or 2. That is the right answer, 2. See, you have the right answer, but inverted. That's right, Timothy. Thank you. Thank you, Kimani. Thank you, Timothy. But the right answer, yes, the right answer is going to be 2. X coordinates of the midpoint is 2. And y coordinate is 7 over 2. It can also represent as 3.5. Those are the coordinates, x coordinate and y coordinate of the midpoint. Thank you again, Timothy. Right, just inverted. Thank you, Kimani. Now we remember, we know how to apply the midpoint formula. Let's move ahead because we will talk about sequences and series, a new topic. And we will start really slowly with basic concepts. Drayden, not a problem. Welcome. Good morning. And one of the basic concepts is this. What is a finite and an infinite sequence? We have two main kinds of sequences. One is finite, another one is infinity. If we talk about, for example, the sequence of natural numbers, and natural numbers are 1, 2, 3, 4, 5, and this will go on and on and on and on, right? We'll have no end. This sequence that have no end is going to be finite or infinite sequence? What do you think? Finite or infinite? If it doesn't have an end, yes, definitely it's going to be infinite sequence, right? A sequence that have no end, don't have a last term. Maybe sometimes, or most of the times, have the first term, but don't have a last term, is an infinite sequence. But if I say, oh, what is the sequence of numbers, natural numbers, between 1 and 100? And then we have 1, 2, 3, 4. This goes 99, 100. This is a finite sequence because we have one last term, we have one last, we have an end to this sequence. All right? Very basic concept, finite and infinite sequences. When we talk about sequences, finite or infinity, we will represent using this notation. A, index n. That means this is the term A, and the index is the order. So the first term is going to be A1, the second term is A2, the third A3, and the nth term is AN. That's okay, Jorge. Welcome back. Good morning. So this is the notation for the term A, and the N represents the order of the term. We are, as I repeat again, we are starting slowly. We will now calculate the term if you give the order of the term. Let's say, usually the sequences have a representation as an equation or an expression, and let's work on this example here where we have the term represented by this expression, 3n squared minus 4, okay? And we need to find the first, the second, the third, and the fourth term. So n equals 1, n equals 2, n equals 3, and n equals 4. Okay? For n equals 1, the first term is going to be equals to 3. Then you plug in n equals 1 squared minus 4. That means the first term of the sequence is negative 1. Next, second term, A2 equals 3 times 2 squared minus 4. And 3 times 2 squared is 4, 3 times 4, 12, minus 4, 8. The third term of this sequence, we can calculate, we can find out. 3 times 3 squared minus 4, 3 times 9, 27, minus 4, 23. And A4 equals, is the fourth term, 3 times 4 squared minus 4. And 3 times 16, 48. 48 minus 4, 44. That sequence will be negative 1, 8, 23, and 44. Okay. And this is a finite sequence because we define that n is between 1 equals to 1 to up to 4. Right? This is a finite sequence with 4 terms. Now, if you have questions, send me. Okay, send a question. Use the chat box. This is an example, a basic sequence that is growing, right? The next term is always greater than the previous one, so it's growing. We can have a sequence that is decreasing if the next term is less than the previous one, and we also can have a sequence that is alternating. Let's understand what it means. Another definition is an alternating sequence. Okay, so let's look at an example, and I think we can understand what means alternating sequence. Let's say we have the term an equals this expression here, negative 1 exponent n times 1 over n, right? This is our this is the equation that represents the term, and now we will find the first, the second, the third, and the fourth term. We just have to plug in n equals 1 into the expression that represents the term. So a1 equals negative 1 exponent 1 times 1 over n, right? And this is negative 1 exponent 1 is negative 1 times 1 over n, 1 over 1, right? This is n. This is equals negative 1. The next term, a2 equals negative 1, 2 times 1 over 2, and negative 1 squared is positive 1 times 1 over 2 equals positive 1 over 2. Now a3 equals negative 1 cubed times 1 over 3. This is negative 1 cubed is negative 1 times 1 over 3, negative 1 over 3. And finally, a4. We stop here on a4, the fourth term, negative 1 exponent 4 times 1 over 4, negative 1. Oops. Negative 1 exponent 4 is positive 1 times 1 over 4. This is positive 1 over 4. Look how interesting this sequence is. The first term is a negative, negative 1. The second term is a positive. The third term is a negative. The fourth term is a positive. It's alternating, right? Negative, positive, negative, positive, negative, positive. That is what means alternating sequence. Any questions? If you find this confusing, don't worry right now, because we're going to practice on the quiz. We will try to understand during the practice, and today we just have to find one term for each question, for each sequence that you have exemplified on the quiz. Okay, it's going to be simple, easy to begin with. Any questions? Thank you, Drillian. Let's find the right answer for the bell work. And we will, thank you, Timothy. We will think as a sequence. We're going to apply a sequence. So let's find what is the A for n equals 1, n equals 2. This is the first year, second year, third year, fourth year, and fifth year. Okay? On option number 1, we will have on the first year 48K. Option number 2, we will have on the first year 50K. Okay? All right? For the first option, we will raise the salary 5% every year. When you're raising 5%, you are multiplying. So this is going to multiplication, will be a multiplication of 100 plus 5%, 105. And when you have this percentage, you have to divide by 100. 105 divided by 100 is 1.05. So you're going to multiply each year, the next, and the next, by 1.05. On the second option, we will add 2K every year. So let's find on the first option, the second year, I have the answer. I have calculated before. 48 times 1.05 is 50. 50.4. 50.4 times 1.05 is 552.9, and 52.9 times 1.05, 55.6, multiplied by 1.05, the next year you're going to have 58.3, right? Now, option number 2, add 2K, $2,000, 52, add 2 more, 54, add 2 more, 56, and 2 more, 58. To find which option gives you more money over the period of 5 years, you add each one of the years and you're going to find the total. If you do this, you will realize option number 2 is going to be slightly better, a little bit better than option number 1. Will give you like $5,000 more. Okay, so you can add all the salaries over the period of 5 years. You're going to find out that option number 2 is a little bit better. And that means the right answer for the period of 5 years is option number 2. But, there is a but. If Justine is worried about after the 5 years, if Justine is worried about what about 10 years, what about 15 years, if she's worried about the long term, maybe option number 1, maybe no, definitely option number 1 will be better because of an exponential growth. The answer will be option number 2, considering the 5 years period. Now let's work on the quiz. This is just to warm up, to get ready, and then we will be able to work on the quiz. Find the end term of each sequence. So on letter A, we want to find the second term. So A2, right? You just have to plug in n equals 2 into the expression that defines the term. 3 times 2 plus 1. And 3 times 2, 6 plus 1, 7. 7 is the right answer. On the other questions, just look at the value of n. This is going to be the third term. This is the fourth term. So notice the value of n and then plug in and find the answer by plugging in the value of n into the expression. All right? Now give me 1 minute. I will check attendance. And after that, we can work on more examples, more questions. So just pay attention to this little thing here, which is what defines the alternating sequence. If the exponent is even, this will be positive 1. If the exponent is negative, you're going to have negative 1. that makes the sequence an alternating sequence. It will be negative, positive, negative, positive, negative, positive. For letter E, let's check here, letter E, we want the third term, right? The third term is A3 equals square root n equals 3. 3 minus 2 is 1. The answer is 1. For letter F, now we will have an alternating sequence. Look at this. This is what will make this an alternating sequence. Because we want n equals 4, right? So A4 equals. If we have negative 1 exponent, an even number like 4, this will be equals to positive 1 times n is 4. So positive 1 times 4, the result will be a positive number, 4. Thank you, Leonardo.